going to be talking about algebra, and we're focusing mainly on 5th grade for this one.
And please speak louder, yeah.
So we're going to keep this brief, the history of algebra. It's hard to say for sure when it started, but it goes back thousands of years, back to the Babylonian times. The word was derived from an Arabic word, al-jabir, which means restoration. At first it was only represented verbally, and then it began being written out. I'm not quite sure how to say this, of Alexandria from Greece. Used shorthand to work out algebraic equations. And it took hundreds of years after him to change, and even hundreds and hundreds of years after that for it to become how we know it. And this just goes on to say that there were many other people who contributed, but this was really when we probably started seeing it how we know it today. And what is algebra? It's a branch of mathematics that uses mathematical statements to describe relationships between things that vary over time. And we call those variables, and those are the things that change. When a mathematical statement describes a relationship, we usually use a letter to represent the quantity that varies. These letters are called variables. And like probability, we use algebra all the time.
Okay, and this is basically a summary of the standards for 5th grade. They represent and analyze algebraically a wide variety of problem-solving situations, perform algebraic procedures accurately, and recognize, use, and represent algebraically patterns, relations, and functions, and define and use appropriate terminology when referring to algebraic expressions, translate simple verbal expressions into algebraic expressions, substitute assigned values into variable expressions and evaluate the expressions using the correct order of operation, and solve simple one-step equations using basic whole number facts, and create and explain patterns in algebraic relationships. And the two that we'll be focusing on during our activities today are the order of operations and then translating verbal expressions into algebraic expressions. So as far as translating verbal statements into equations, in algebra, a verbal problem is solved when the value of its unknown is found. In some problems, it's necessary to translate verbal statements into equations using a letter to represent the unknown. So for example, if someone says twice what number equals 12, and you want to put it into an equation, you would write 2n equals 12. And this is just these are a few examples of that, but we're not going to actually do them.
This is one of the activities you could do, but...
Right, just like if you see 4 less than what number equals 8, you'd want to put it into an expression. It would be like x minus 4 equals 8. And this is the activity that we're not actually going to do, but what we would do to practice this skill would be hand out a sheet of paper that would have this on it, and have kids work with partners and cut out each box and then glue the statements that match the equations next to each other, just to practice matching them up.
So this is the activity we're going to do with everybody, and we're calling it Come to Order, because everything in algebraic equations is about order. So we would present it to a class in such a way that we would try to get everybody involved and ask people, where do you have order? Why do we need order? And when do we need order? So, I mean, you guys could call out if you'd like, but you don't have to.
Like in the morning, if you're like getting ready for school, you would brush your teeth after you eat breakfast, because, you know, or things like that, like what order you would do things in.
Another thing that comes to mind is like the Army. There are sergeants, there are lieutenants, and that's sort of how we would try to explain the order of operations. What do we know about order in math? And exponents, what does this mean? We would have the students say it. It's 2 to the 4th power. You could even show it by having someone stand on a chair, and the one that's higher is the exponent, and that's what you keep multiplying by, just to show some visual along with it. You would have them write it out, solve it, and then we'd move into an algorithm, and we would discuss what an algorithm is. And do you know what I'm heading towards here, or about order of operations?
Or an acronym that represents.
No, I said algorithm and then acronym. My spell check didn't work. PEMDAS, right. Okay. Oh, they didn't. So work with a partner and cut out 6 strips of paper measuring 3 by about 8.5. One to stand for each letter of PEMDAS.
You don't have to actually use a ruler or anything, just,
Yeah, just
so you have enough strips to write.
right. These were supposed to fly in.
The animation.
They were supposed to come flying in, but they didn't.
Yeah, I'm not a fan of Smart Notebook.
It worked yesterday.
Yeah. It's very picky.
And then use your markers to write each one of these. Parentheses, exponent, so on and so forth. Yeah. And for the students, you can have them decorate them any way they want. They can have the first letter being, big and bold. It's just sort of to get them involved and working in small groups and individually. And at this time, you would just be walking around and...
When you help cutting.
Everybody good?
Yep.
Okay. So let's start here, and how you would lead your class is to say, I want you to hold up the expression of how you would start to solve this expression. So what would you do first here? And hold up your sign and
Okay.
yeah, you could do one per pair. And that's how you would go through each one. And we would like to get somebody up here to come and solve it, and they could use a smart board themselves.
Would anybody like to come up?
If anyone wants to come up and solve. And then after you write out the exponent, then ask them to hold up which sign.
It's not really lined up.
Yeah.
It needs to be calibrated.
Okay, what's next?
Right, the rest,
Right
right.
Obviously way off.
Yeah, it's very off.
Didn't you? Oh, right.
Yes.